7.3. Use functions involving E.
I like this.
So you're probably like, what is E? Well, E is a number.
What?
No, E is a letter.
E
So killing everything
is
else.
Euler's number. We call it natural base E.
I thought I was gonna like this session.
You will. So the definition of E is the natural base E is irrational. It is defined as follows. As n approaches positive infinity, so we have the limit as n approaches infinity is how we would normally be writing it. 1 plus 1 over n raised to the n approaches E. Wait, hold on. I need to write this way. There we go. I have it on two different lines in my thing. It's annoying. So the limit as n approaches infinity of 1 plus 1 over n raised to the n approaches E. Anybody know what E is equal to? Approximately.
2.71.
Yep. Which is approximately equal to 2.718281828. We normally will just use 2.71, like with pi we would do 3.14. Typically we'll just do 2.71. Some people will celebrate E Day on February 17th, even though it's backwards. It's kind of like the closest thing that we can get to it. Obviously, people want to celebrate E, so.
Or in 2071, we can just dedicate the whole month of February.
Or you could just do like January 27th.
Or
Anyways.
just not celebrate
Yeah.
random
Random
numbers.
numbers.
They don't need a day.
I didn't even know it was like a thing until like a couple years ago, and somebody was like, yeah, like we have our E Day celebration. I was like, what?
I have a friend who's a math major who crashed out when I told her that we had like a Pi Day thing in like at school. She was like, why are we giving so much stock into this number when other numbers like E are so much?
Because we don't ever get to have fun in math. All other subjects get to have fun, and we don't. So we have fun on Pi Day. Mainly just because I want to eat.
Yeah.
Bottom line. No, wrong thing. All right, so natural base functions. A function of the form y equals ae to the rx is called a natural base exponential function. And similar to what we had yesterday, if a is greater than 0 and r is greater than 0, then the function is an exponential growth function. If a is greater than 0 and r is less than 0, then the function is an exponential decay function. And I'm not going to redraw what these would look like. They would look the exact same as what we did yesterday as far as the actual graph of growth and decay, even though it's e, because e is just a number. All right, continuously compounded interest. I don't think I've ever found a bank that will continuously compound your interest, but I wish I did because basically it just means that you're constantly earning interest. So like most banks, it's like once a month. I say most banks. Some banks are once a month you earn interest on your savings account, typically not on checking, which is why it's better to have your money in your savings account than your checking account. Even if you do get something on checking, it's not usually as much. A credit union's going to give you more interest than like a Chase or a Wells Fargo or a Bank of America or something like that. Credit unions give you more interest. And typically more often, but some of them are like once a quarter or whatever. Compounded continuously means like it's like almost like every day, but it's like constantly happening. But like I said, I've never seen this in practice. I've actually happening. I've only ever seen it on paper, and like I don't know who compounds interest continuously, because that would be so much better in my opinion. You would be earning, but usually the rate would be lower, so I don't know. Anyways, neither here nor there. Next year, you'll learn all about all the different formulas for interest, if it's compounded quarterly, monthly, daily, annually, all those fun things. There's all different formulas for that, but this section is continuous, and you'll see why the formula in just a second. So when interest is compounded continuously, the amount A in an account after T years is given by the formula A equals P e to the RT. Where P is the principal, which just means the initial amount that we put in, and R is the annual interest rate expressed as a decimal. So in the grand scheme of things, if we compounded our interest daily, we're not going to get that drastic of a difference in interest as this. This is more like a limit as like we get like closer and closer to it, essentially, is like what's happening. So in the grand scheme of things, we're not going to have it that drastic of a difference if we do this versus compounding it daily. But anyways, like I said, you don't ever hear of that. One, you don't hear of people compounding your interest daily, and two, that would be like if you loaned your friend money and they said like every day you're gonna owe me more money, like that would kind of be that situation. But this just, I don't know, on paper is often what gets used. I'm sure somebody in the world uses it. I just haven't seen it. Anyways. In A, I don't really know if we put that. Well, yeah, after 2 years. And then T, just however many years you want to see when it happens. So, all right. So, simplifying the expression. So, this is kind of going back to rules of exponents. So, 4 e to the negative 2 times e to the 6 would be what? Yep, e to the 4th. 6 in parentheses 2e to the negative 2 raised to the negative 4. With what?
Negative 4.
So 1 over 2e to the negative 2 raised to the 4th. Now what?
And then you multiply it out to the 2, giving you 64, and then positive 2 for the exponent of e.
That's not 64.
16.
Or 16, yeah.
Yeah. I'm just going to do it this way for a second so that we can see it. But it would be 2 to the 4th and then e to the what?
E to the 2. Powers 2. Because you... Or no, power
It's -8.
Negative 8. We multiply. Now what do I have to do?
What we're writing.
Yeah. So e to the 8 over, we already said that was 16. I just wanted to write it the other way so we could see what was happening. This is a fun one. E to the x times 5e to the x plus 3. Any ideas?
Raised to the x squared plus 3x.
Well, they don't. They have the same base, so we just add them.
Yep, same base, so we add. So this would be 5e to the x plus 3 plus x. So this ends up being 5e to the 2x plus 3. (14) 6e to the 4x over 8e.
Just simplify.
Well, that's
That's the first
the
step.
instructions. Y'all must be tired. Y'all are quiet.
I answered the last one.
You gotta divide both sides by 2.
Huh?
Like
Simplify the 6 and the
You can
8.
take the 2 out of
Okay.
the 6 and the 8. And then the e from the bottom moves to the top. So it becomes e to the 4x minus 1.
Yep. All right, your favorite part. Use a calculator to evaluate the expression. All right, so when we have these ones like this is e to the negative 3 over 4. Over here, above the ln on the left-hand side, you'll see a little e to the x. So you're going to hit second ln, and that's going to bring up e with a box that we're filling in. So e to the x, that's just saying you're going to be filling in whatever that is. When you do this, you need to use the little negative sign that's at the bottom, not the minus sign on the right. So negative 3 divided by, well, I just hit clear. Negative 3 divided by 4. And it wants them rounded to 3 decimal places. So this will be equal to 0.472. .4 e to the 4.1. So with this one, just do 0.4, then second ln, which brings up our e raised to the power, 4.1. And we'll get 24.136. Tell whether the function is an example of exponential growth or exponential decay. We're not going to graph it, but yes. So 32 f of x equals 1/3 e to the 4x. Okay, so up in our notes we had that if a is greater than 0 and r is greater than 0, it's an exponential growth function. If a is greater than 0 and r is less than 0, it's decay. So a is greater than 0, it's 1/3, and r is greater than 0 because it's 4, so it's growth. .34 f of x equals 3/5 e to the x. A is greater than 0. What about r? Yep, it's greater than 0 because r would be 1. So this one is also growth. F of x equals 4e to the negative 2x. So a is greater than 0. What about r? So Ryan, it is
Decay.
easy enough.
Decay sounds so much more serious than growth. I don't know. It's like exponential.
Yeah,
growth.
unless you realize that this is often talking about bacteria growth.
We use numbers for that one.
I mean, they do, but
Oh.
we'll see this more. Well, I don't know if it'll be in our book, but later on you'd see more that, like, typically when we're thinking of like growth and decay, we're looking at like bacteria growth or like radioactive decay to attempt to figure out how old something is, when most of the time with carbon dating and all of those things, they will say that things are millions of years old, which we know can't be true. So I don't tend to do a ton of the decay problems when we do get to word problems with that, just because it doesn't give us accurate information. Not that it's not good to know, but it's not realistic. So anyways, or like half-life. Same thing. All right. Word problem.
It's already one form. Why are we using those?
You deposit $800 in an account that pays 2.65% annual interest, compounded continuously. What is the balance after 12.5 years? So our formula, yep, A equals PE to the RT. Did my mom teach you that?
No.
No. She always says PERT, so that's why I was asking.
That's what I thought when I saw it.
That's fair.
That's why that
That's what she always, like, says it, so.
They're all like,
I contemplated if I should take that down while ACSI was here, but it's just a physics formula.
are you gonna say it's 2 pi squirt milk if they ask?
What?
Are you gonna tell them it's 2 pi squirt milk if they ask?
No, it's a physics formula for the period. Alright, so P is our principal, so that's $800. The rate is 2.65%, but can I put a percent in an equation?
No.
What do I need to do?
Go to decimal code to the left twice.
So 0.0265 is really what R is, and then T is 12.5. So A equals 800 E raised to the 0.0265 times 12.5. And then you would have to type this in your calculator. So see, Ryan, this will be one of your favorite problems, even though it's a word problem. It's a calculator question.
Still writing it down.
So after 12 and a half years, our grand total is $1,114.17. Now, how many decimal places does money have? 2. So our money answer should always have 2 decimal places. I have had people before that it was like essentially 40 cents, and they have gone and put $150.4.
0.
Yes, it's money. It's got to have 2 decimal places, okay? So in pre-cal, there's like literally like a whole section that's all these kind of problems, but it's like all the different like formulas, and like you can figure out like your loans and anyways, all kinds of stuff. And for like the 1 year they kept doing it, I had to keep being like money, 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 like trying to get them to like realize it's 2 decimal places. Anyways.
At Chick-fil-A in Tennessee or something, like all the Chick-fil-A cash registers had like 5 decimal points after everything. So like a Chick-fil-A sandwich was like however many dollars and like 7.535 cents. It was really like a weird.
That's really
I
weird.
don't know. I've never seen anything like that before.
Interesting. Now, by the time we're done with this chapter, you will be able to figure out how long it will take you to get to what amount of money you want to have. So we'll be able to figure out if you want to start your account with $1,000 and you want it to end up having $5,000 and you're never going to touch it, how many years it will take you to get to that amount based on the given interest rates and all of that. But we can't do that yet. You haven't learned how to do that.
Is it a log?
Yeah.
Okay.
All right. Any questions? Cool. 5, 9, 11, From 19 to 30, pick 2. 33, 37, and 57. So 57 is a word problem. Literally just like this, just different amount of money.